So again, this is our, whoops, go ahead and pull up your magic formula sheet. So this was the other handout you were supposed to do today. It's right here. And I'm going to have you guys do a couple things to it, and I just realized that I think I'm not going to be able to write on this, so I'm going to use this one here. Oh, did I not even do that?
Do those couple of sheets go on notes in our binder, or?
No, this is just a standalone. So if you picked up the handouts, it's a hard copy yellow sheet, and the beauty of this sheet is that you can actually, let me see where this comes in right here. I will actually allow you to use this on your exam. So this is one of the most useful handouts people have, because you're allowed to use it on the exam.
Along with the other sheet?
No, the other sheet you can't. So this sheet here, you cannot use this one on the exam. So this one, you can't use it on the exam. However, it helps you figure out what to put on the half sheet of notes. So you are allowed that half sheet of notes on the exam, and also this. This has all the formulas.
Okay.
Yeah. So first off, take your sheet and draw a thick line down the middle and across the middle here, and we'll take a look. So if you look at that, the left side and the right side, what's the difference between the left side and the right side? It says the left and the right is, this is a confidence interval, an estimate. This is a hypothesis test. So these formulas are all for confidence intervals, right? How to find the critical value, which actually used for both of them, but this one is just for confidence intervals. What is a confidence interval? It's x bar plus or minus your e, where your e is this. Also, how do you find your minimum sample size? So you can see your minimum sample size, the formula for that. For a hypothesis test, this is the one you just used a second ago, right? X bar minus mu naught over S over square root of n, right? The critical value, though, goes for both. So the critical value goes for both the hypothesis test and for the estimate. This column here is valid for both of them. But this stuff over here is just for the hypothesis, how to find your p-values, how to find your test stat, where your h naught should always be in these cases, because h naught is always equals, so what it will be. And then what about the top versus the bottom? This top half versus the bottom half, this line here, this dividing line here. What's the difference between the top and the bottom?
Means versus proportions.
Yeah, means versus proportions. These ones are means. You see how it says means here, and these ones are proportions. See where it says proportions there? Please note that the top row is for one sample. That's what we've been doing, this top row. The second row, this second row here, this is for two populations, two samples. That's what we're going to be doing next in Chapter 9. So these are the ones you'd use if you had two samples. And again, same down here. One sample is this top row, two samples, two proportions is this bottom row, the formulas you use for that. One thing I want you to change here is where it says degrees of freedom. You guys see where my cursor is? I have this big X here in red, degrees of freedom. Instead of this big, giant, crazy, messy formula, your book just uses this. Degrees of freedom, you use the smaller n, because remember you have two samples, so you have two n's. You got n1 and n2. Use the smaller one of them, minus 1. So degrees of freedom equals the smaller n, because you have two n's, two samples, two sample sizes, two n's. Use the smaller n minus 1. Cross that out, write in this instead. Chris, are you good? Are you with us, or is this, oh, that's old. Oh, that's really old. Okay, my bad. All right. Okay, So again, you can use this. This is great. You can use it on exams. This was done by my old friend Alan Longmire, who's now retired and living in Washington. But it was really a nifty thing he came up with, so I had him customize it for my students, and I'm letting you guys use it on the exam. All right, great. Using the TI 83, 84 to do stuff, so we kind of talked about this a little bit last class. Just a reminder, if you're talking about an interval, confidence interval, you're going to use, go back and do this one actually, I think it's a little faster. There. You're going to use the t-interval for means, right? If it's your find confidence interval for means, and if you're talking about proportion, confidence interval for proportion, you're going to use 1 prop z interval. And then for tests, you'll use a t-test for a mean, because a mean, Mr. T. You'll use a 1 prop z test for proportions. Just remember, easy peasy, that's where that z comes in, 1 prop z test. Okay. And then, you know what, I'm going to skip this one. I'm going to go into Chapter 9. So now pull out your Chapter 9 notes. Chapter 9 notes. You need those. Grab them. They look like this?
Mrs. Young,
Yeah.
by any chance, are you posting somewhere what notes and quizzes we need for each class? I know before but I'm not.
I put them in the announcements. So I email you guys. I don't know if it's in the announcements, but in the email I send you guys each week, it's in the email I send you guys each week. I talked about what you need for this class for the week. And I think it's in the announcements. If not, then I'll make sure I put them in the announcements, what you need for that week.
Okay.
Yeah, and maybe I can try to put that in the front section, just a quick comment in that top one where it says see announcements. Maybe I'll try to add it in there and say, you know, this week you need this, and I'll have to change it each week. But I will try to do that. Okay, so this is the one you need this week, or today, and I believe I'm having you guys turn in this page here, page 22. I haven't put it in yet, but it will be this page, 22. Okay. So now, you know, we've taken our sample, we've found the X bar or the P hat and the S or the other stuff. What do we do with that? And that's the inferential. This is the inferential side of statistics. So talks about what the goal of the experiment or survey is. So you can either, if you don't know what the mean is, you can estimate it using a confidence interval. That's Chapter 7. Or if you do know the population mean and you want to see if your population differs, right? Your sample, your group differs. Your school is different than everybody else. Like that last principle in the last problem. Then you can do a hypothesis test to compare your population to the general population. And that's Chapter 8. What we're going to be doing in Chapter 9, right, is 2 samples. And we're going to compare 2 samples to see if they differ somehow. So we're going to do a 2 sample test. Here are some requirements. You need proportions from 2 independent simple random samples. For each of the samples, the number of successes has to be at least 5, and the number of failures has to be at least 5. So this is for proportions, 2 sample proportions. So you're taking a proportion from one group, and you're taking a proportion from another group, and you're going to compare them. Like you might take boys and girls and say, you know, how many boys, we'll do this one later, yeah. How many boys own a pet, and how many girls in the class own a pet? And take those 2 percentages and compare them, something like that. Or maybe you might compare math majors and history majors and take a sample of history majors and take a sample of math majors and see, I don't know, what percentage of them are taking 4 or more classes or something like that. So you're going to take 2 independent samples from 2 different groups, and you can compare those samples. So you can compare the groups. All right, so remember, The null hypothesis for two proportions is always, always, always no or none, no difference, which means that they're equal. So we have two different groups. We're saying that their proportions are equal. So the proportion of boys who own a pet is the same as the proportion of girls who own a pet. They're equal. Another way of saying that is the difference between them is 0. There's no difference between them. So if I subtracted them, I should get 0. So you can use this for your H naught. Alternatively, you could write it like this as well. But this will come into play when we get to our test stat. We'll talk about that later. So here, first of all, we have a pooled sample proportion. So it's going to be, the pooled sample is called P bar, and it's x1 plus x2 over n1 plus n2. And then Q bar would just be 1 minus P bar. So a couple things to note. Remember that P is equal to x over n, where P is your population proportion, n is your sample size, x is your number of successes. So you should be writing these into your notes.
The last slide said H naught is P1 equals P2, correct?
Yes. H naught is that P1 is equal to P2. That's the very first thing you're filling in on your notes. All right, so then let's talk a little bit about this pooled sample. So let me flip back to here and talk to you guys again. So let's assume, oh, yep, we're good. Okay, so let's assume that, see if I change it to speaker view, let me see if I'm big. No, I'm not big. There, oh, that works. Okay, great. So let's assume that we have, we have men and women in our class, right? So let's take the percentage of, say there's 20 girls in the class, and out of those 20 women, say 6 of you have dogs. So our proportion for our first sample, the women, would be 6 out of 20, right? 6 out of 20 have dogs. And then we'll look at the men in the group. And out of our class, say out of the men we have 14 guys in the class. And out of those 14, 7 of them have dogs. So 7 out of 14 would be the proportion of dog owners in our class. So we have two proportions. We have the ladies, 6 out of 20. We have the guys, 7 out of 14. Those are our two proportions, the two groups we're comparing. When we pool them and put them into one big pool, right? Like remember carpools when you put everybody together? So one big pool, then we're saying that there are 7 plus 6, 13 dog owners out of 20 plus 14 people. And so that's kind of what we're looking at. So here, that's the pooled thing. You take the 6 out of 20 and the 7 out of 14, and you're saying there are 6 plus 7, 13 total out of 20 plus 14, 34 total. That's when you pool both groups together into one group. That's your proportion. And then Q bar would just be 1 minus P bar. And go ahead and find this as a decimal and give me 3 sig figs on it. Okay? So that's what you need to do. So why don't you guys go ahead and do lab problem number 1. And if you don't have your notes for whatever reason, then here is lab problem number 1. There. All right, so just take a minute and do lab problem 1. Welcome back. Okay, so this is what you guys have. All right, so your p hat would be x over n, 20 over 36, 0.556, which you round to 3 decimal places. Then q hat would be 0.444. And then find the p bar and the q bar. And that is going to be, so one thing about this top one, just so you guys know, sometimes I'll give you p and n and have you find x, right? So sometimes I'll give you this p hat and you'll have 36 and you have to find the 20. So you know that these two, this p bar plus multiplied by your n gives you your x. So sometimes you have to work it the other way around too. All right, P bar and Q bar. So P bar is going to be, I had 18 plus 20 successes out of 60 plus 80 people, so 36 over 140, 0.271, and then Q bar is 1 minus that, 0.729. Okay, so you guys should be all good with that part. And then we'll go ahead and move on. All right, so the test stat, everything else stay the same. Steps 2, 4, and 5 stay exactly the same. Steps 1, we had that slight change, minor change, but those all stay the same. The only thing that changes is step 3. So your test stat is going to be, and I think your notes say Z, but you can change it to test stat. It's P hat 1 minus P hat 2 minus P1 minus P2 over square root of P bar Q bar over N plus P bar Q bar over N2. And your notes actually have it like this, which I think is a little bit easier to use. So maybe go with what your notes have. I think that's a little bit cleaner and easier to use when you calculate stuff. But here's the catch. Remember, in null hypothesis, we assumed that P1 equals P2. So when you subtract them, you get 0. So what we expect is that when you subtract them, the difference is 0. So this just goes away because we expect that to be 0. And you're left with just this part here, which is exactly what you have in your notes. The bottom right side of your notes, whoops, will have this part right here, just like this, just says that. And again, I think yours actually says it like this, which I think is a little bit easier. I think that's kind of better, so use that instead. And don't go thinking this is different than what we've been doing in the past. Same test stat as before. We take what we got from our sample, difference of the two samples, and you subtract what we expected to get from our claim, right? So our claim was that they're equal, so we expect to get a difference of 0 divided by whatever the standard deviation is for that group. So it's the same as all the other ones. These all follow that method. Your sample minus what you have in your claim divided by your standard deviation, standard error. All right, so let's go ahead and do an example. So this is the beginning of page 22, which is what you're going to be handing in today. So I'm going to have someone go ahead and read this for us. Yusur, can you go ahead and read it for us? Go ahead.
If the nursing home study mentioned in the chapter opening statistics today, the researchers found that 20 out of 34 small nursing homes had a resident vaccination rate of less than 80%, while 17 out of 24 larger nursing homes had a vaccination rate of less than 80%. As alpha equals 0.05 states that claims that there is no difference in the proportion of the small and large nursing homes, with a resident vaccination rate of less than 80%.
Perfect, thank you. Great. So first of all, how do I know this is a proportion and not a mean? So you might say, oh, there's this 80% here, right? But we can't go off of that because this 80% is not the percent that we're looking at. This is just part of the question. This is what we're asking people. We're saying, is your vaccination rate less than 80%? Yes or no? So this is our question. This is not one of the proportions. It's not that they have a proportion of 80%. This is the question. Is your vaccination rate less than 80%? Yes or no? Right? Hopefully it's no, because the vaccination rates should be higher than 80%, especially with COVID-19 running around. Not that there's a vaccination for it. All right, anyway, so how we know it is that, first of all, there's no mention of the word mean or average in here anywhere. And you can kind of look at this and say, vaccination rate is less than 80%, that's going to be a yes-no question. So this is our qualifier, this is our question. So our question is a yes-no question, then we know it's a proportion. And then also, we have a proportion in the sky, a fraction here. So those are kind of our ways of knowing that it's a proportion, right? So this is, so don't look at these 80%. Those are the question that was asked. The proportion is really these guys here. We've got two. We've got one for, so this is a study. So this is my p-hat. In the study, we found this. So we're testing the claim that there is no difference. That means my claim is no difference. Let's go and take a look at here. Our small nursing homes, small, is 12 out of 34. So that's my p-hat for the smalls. 12 out of 34, 0.35. My p-hat for the larges had 17 out of 24 who said they had a vaccination rate of less than 80%. So that's not very good. 17 out of 24, so that's a 71% of them had low vaccination rates, whereas only 35% of the small ones had low vaccination rates. So we're going to go ahead and find our, that's our p-hat 1 and our p-hat 2. You should be writing those down, right? That's how you find them. And then you need to find our p-bar, our pooled one. So our pooled one is going to be 12 plus 17, our total number of yeses, 12 plus 17 out of our total number of people asked, 34 plus 24. So it's going to be 29 out of 56, which is 50%. That's our p-bar. And our q-bar is 1 minus that. So if this is 50%, that's also 50%. Because 1 minus 50% is 50%. All right, so that's before we even have steps. This is just the beginning part. Okay, everybody got that written down?
One more minute, please.
Okay. And again, this is, well, yeah, this is not too. All right, so our alpha is 0.05. Okay, so now let's take a look. What am I testing? What's my claim? Everybody look up and see this part. The claim is that there is no difference in the proportions. The claim is no difference, and the proportions, now the claim is that they are equal. No difference means equal. So my claim is that these two proportions are equal. Is everybody on board with that part? That's my claim. See right here where it says claim? Claim is no difference in proportions. No difference equals. So that means that my step 1 is going to be that P1 equals P2. That's my claim. So H naught is always equals. So H naught will always be that P1 equals P2. Since that's my claim, then H1 will be that they're not equal. It'll be the opposite of that. Oh. Yep. All right. Actually, that's not much helpful. So again, my claim was that there is no difference, so my claim is H naught, which means that H1 has to become the opposite of my claim. That also means that since H naught is my claim, I'm going to be using the word reject, because if my claim is H naught, I'm always going to use the word reject in my summary. If my claim was H1, then I'd always be using the word support in my summary. My claim is H naught, I'm going to use the word reject, so write the word reject in there next to it. Next, we're going to find the critical value. So here, alpha is 0.05. I'm going to pull up my t-table. And it is, alpha is 0.05. It's a two-tailed test because it's not equal to, so two tails, 0.05. And it's a proportion, easy peasy. I'm going to use the z-table, which is all the way at the bottom. This is my z-table down here. So right here you can see 1.96. That is my critical value. It's two tails, so it's going to be positive and negative 1.96. So I'm going to draw my little picture, shade it, put in negative 1.96 and positive 1.96. Then step 3, compute the test value. Again, remember we're ignoring this part here, so you guys just have this portion here you worry about. So p hat 1, which is 0.35, minus p hat 2, which is 1.71, over square root of p bar q bar, 0.5 times 0.5, times, in parentheses, 1 over n1 plus 1 over n2, 1 over 34 plus 1 over 24. You need to do this part first. So let's go ahead and go through that in our calculator. This is how we do it. All right, I'm going to start from the inside first. So the most inside is inside the square root, and then within that, inside the parentheses. So right here, 1 over 34 plus 1 over 24, and since division comes first, I can just do that. All right, so then that's this part. And then you multiply by these guys. I'm working my way outwards, right? So working outwards, I do times 0.5 0.5 times 0.5, enter. So that gives me this stuff inside. Now I need to square root it. And again, the easiest way to square root it is to raise it to the 1/2 power. So I'm just going to go raise it with this little caret thing here. Raise to the 0.5 power, right? Raise it, that's the power, 0.5. Raise to the 0.5 power, 1/2 power. That square roots it. So that's my bottom. My bottom is 1.333. So give yourself 4 or 5 decimal places. 1.3330. Then find the top. 0.35 minus 0.71. Enter. That's your top. Take the top, divide by the bottom, divide by 0.13330, and there I get negative 2.70. So that's my test stat. Negative 2.70, and you're going to put it in where it goes in to your picture. $2.70. If I owe $2.70, that's worse than owing $1.96. That's to the left over here. And if you're not sure again, just take out the decimals. Give them the same number of decimal places, 2, right? So they're both 2.70, 1.96, and then ignore the decimal places. Negative 196, negative 270. Negative 270 is worse, so that's going to go. It's going to be on the left side. Okay, so here, clearly, this is my rejection region. This is my guilty region. So I'm going to reject H naught. Everybody on board with that? This is my rejection guilty region, which means I had enough evidence. So I'm going to reject H naught, because remember, H naught says that I am here. This is what H naught says. H naught says I am smack dab right here in the middle. If I get something way out here, H naught's wrong. I'm not right smack dab in the middle. I'm out here. So H naught, if I get something in this range here, then that's like, okay, well, maybe H naught's correct because that's not that far off. But if I get something way out here, H naught is wrong. I am not here in the middle like H naught says. I'm over here. So we're going to reject H naught, which means that there is enough evidence because we rejected H naught to reject the claim. Remember, you wrote reject down next to H naught because that was your claim. To reject the claim that there is no difference in proportions of small and large nursing homes. And you can just put difference in the vaccination rates of small and large nursing homes. You can put that instead if you wanted to. That'd be fine.
Can you go back to the last slide really quickly?
Yes, just for a second. Okay, and then we're moving off of that. Again, remember these are all going to be posted under BoardWork PDF in Canvas, so you can always go back and do those later if you want. These you don't need to hand out post these. You will need to turn this in, take a picture and turn it in, but you don't need to do that until tomorrow night. All right.
Now on step 1, we stated H naught is P1 equals P2.
Yep, always. H naught is always P1 equals P2. Always, always, always equals.
Oh, we left it like that, but we would plug in the numbers of P1 and P2.
No, you would not. Because you don't know P1 and P2. You know P hat. You know P hat. You know P hat 1 and P hat 2, but you do not know P1 and P2. You only know P hat 1 and P hat 2. You don't know any of these. So that's a great, thank you for bringing that up, Noe. It's going to be just like this because we don't know what these numbers are. We know what our p hat 1 is, but we don't know what P1 is. Right? Remember, this is our sample. This is what our population, which we're guessing at. We don't know yet.
Okay.
So yeah, excellent point. I'm glad you brought that up. So yeah, so this stays exactly like that because we don't know either one of these. We haven't sampled everybody. We haven't sampled every single small nursing home in the world. We haven't sampled every single large nursing home in the world. So we don't know these two. We only know P hat 1 and P hat 2. So this stays just like that. So that's the thing about the two samples. The two samples, there's not going to be numbers in them. They're always going to be letters. Always. So why don't you guys go ahead and do lab problem number 2. I will give you guys 15 minutes in your groups. So go ahead and hop in your groups, and I will give you guys 15 minutes to work on this.
I have a question.
Yeah.
So I have to do the 5 steps, right? For every problem, I have to do every step.
Yes, you have to do all 5 steps for everyone. Is that your question?
Okay.
Oh wait, you know what? I'm going to bring you guys back in real quick, sorry. Sorry. I'm going to go ahead and have someone read this before we go and point out a couple things before I let you loose. Come back. All right, let's get someone reading this. Chris, can you go ahead and read this for us?
Problem number 2, male and female workers. A survey of 200 randomly selected male and female workers, 100 in each group. Found that 7% of the male workers said that they worked more than 5 days per week. 12% of the female workers said they worked more than 5 days per week.
Alpha
equaling .01 can it be concluded that the percentage of males who work more than 5 days per week is less than the percentage of female workers who work more than 5 days per week.
Great. So again, these 5 days per week, that's just to throw you off. That is not, that's the question. Do you work more than 5 days a week or not? That's not one of the numbers you're going to be using. This is just part of the question, the qualifier. Did you work more than 5 days a week, yes or no? So it's a yes/no question, so it is a proportion because, again, there's no word mean or average in here anywhere. And then you'll also notice that this 7% of male workers said yes. Remember, I'm always going to give you in the proportions, I'm either going to give you the actual p-hat proportion or I'm going to give you the number of yeses. Is this 7%, is that the number of males who said yes, or is that the percentage of males who said yes? It has a percent on it. It's the percentage. Yeah, exactly. So this is your percentage. So you don't have to put this over 100. My n is 100 in each group. This is the percentage. It's not the number of people. However, you do need to find the number of people. So 7% of 100 means multiply. So your n is 100, your percentage is, your p is 7%. You have to multiply those two to find your x. So your x is going to be equal to np. All right, so 100 times 7%, that will give you your x. So you'll need to use that to find your x. Okay, good. So now I'll open up and let you guys go. Just make sure that you realize that this 100 is your n for each group. 100 for your first group of males, 100 in the females, and then these two numbers are the percentages. Okay. So you're going to need to find your p-bar. Go ahead and do that. Okay, so we are back. Let's go ahead and take a look at what you guys got here. So this is what you guys should have gotten. So our p hat 1 is 0.07, my p hat 2 is 0.11. My p-bar is 7 plus 11. If you're watching, incidentally, if you're watching at home, go ahead and pause now because I forgot to change the video, so just pause it and come back to it later on. This is about the 35-minute mark, and then you just come back to this later. All right, and then p-bar is, again, I had 7 out of 11. So if I had 7% of 100 people, how many yeses did I have? 7% of 100 is 7, because 7.07 times 100. Oh, here it is right here. Right, so x is equal to np, so it's n is 100, p is 0.07, that's where this 7 comes from. And the 11 comes from the same idea, 100 times 0.11. So 7 plus 11 yeses out of 100 plus 100 people, 0.09 is your p-bar, and q-bar is 0.91. So then, your claim is that the men have fewer men that worked 5 hours or more, or 5 days or more than women. So P1 should be less than P2. That's your claim. All right. So then H0 is always equals. So H0 is that P1 is equal to P2. Those proportions are equal. Since H0 is not my claim, then I have to make H1 my claim. H1 becomes P1 is less than P2. So that's my claim, which means I'm going to use the word support down in step 5. So because H1's my claim, whenever H1's my claim, I'm going to use the word support. So write that next to it. All right. So then, looking up in the table, I get, let's see, I have n minus 1. Did I do that? No, I didn't. All right. So n minus 1. So my smallest n is 35, I think. No, 100. Oh, it doesn't matter. It's a proportion. Duh. This is a proportion. So we just look at the table under one-tailed test for alpha 0.01. Proportion. One-tailed alpha is 0.01. Here we go. The middle column. And we get 2.327. So that is 2.33. So it's going to be negative because it's less than. So I'm going to draw my picture, left tail, negative 2.33, that's my critical value. So I'm going to find my test stat. So my test stat is going to be, make sure it's in the video, is p hat 1 minus p hat 2 over square root of p bar q bar times parentheses 1 over n1 plus 1 over n2. So 0.07 minus 0.11 over square root of 0.09 times 0.91 times 1 over 100 plus 1 over 100. So when you do this and square root it, you'll get 0.0405 down below and negative 0.04 above. And when you divide those, you get negative 0.988. So negative 0.99 is my test stat. Goes right in here. Totally in the non-guilty range. So we do not have enough evidence and we do not reject H0. So everyone good with that? Not guilty, do not reject H0. It's in the...
Can you elaborate a little bit for number 5, please?
Yes, I will for number 5. So here, because we did not reject H0, then we did not have enough evidence. Those two go hand in hand. So those are always going to be the same. Not here means not there. They will always match up. If I do not reject H0, I do not have enough evidence. Always. Those two, that's where this one comes from. Whatever it says here, if I do reject H0, I do have enough evidence. If I do not reject H0, I do not have enough evidence. Is everybody good with that part? And then the other thing that comes in. Yeah? Keep going.
For the critical value, do you want us to always route it to 2 decimal places from the table?
No, you don't have to. You can do 2 or 3. I don't care. I think your textbook might want 2, but I don't care.
Okay.
Okay. And then enough evidence to support. And again, this comes from this up here, right? Because H1's my claim, I'm going to use the word support, which means I'm going to use the word support down here. Those guys match up. It goes to that spot there. That's where that comes from there. So there is not enough evidence to support the claim that men work less than women. Yes? No? Or less overtime than women? So maybe they do, but I can't prove it. So let's go up to, go up here. See how we're in this range here? So maybe they work less, 7% versus 11%, but I don't have enough evidence. So it might be true. I don't have enough evidence to support it. So my claim that men work less overtime than women, maybe it's true. I do not have enough evidence to support it. Could be true. All right, good questions on this one? All right, I'm glad because we need to move on. All right, the next page, page 23. So page 22 is the one you're going to be taking a picture of and submitting for your assignment for today. You can do that anytime between now and the next week. Ideally, between now and the next week. Ideally before next class, but anytime between now and next week. Since you guys are here, it doesn't really matter. Just before next week so I can grade it. Page 23, we're going to skip that. Just put an X right through there. We are not going to worry about confidence interval estimates of two proportions. The next page it says, it's page 24, two population means, independent samples 9.3. Couple things that are important. Both have to be simple random samples. They need to be independent of each other. In other words, the group in one sample cannot have a relationship to the group in the other sample. And then the sample size is less than 30, then it has to be normally distributed or approximately normally distributed. That's fairly standard stuff. Then we're going to take a look at this. So we're going to fill this out. Did I fill this? Oh, no, not that one. Ignore that. We're going to fill this out. So my H0 for this is going to be mu1 equals mu2. That's our H0. And we're going to use, for degrees of freedom, we're going to use the smaller n minus 1. So then we talked about the different things we have. So for every sample, we're going to have a mu1, population mean. We're going to have an x bar 1, sample mean, an S1, sample standard deviation, and an N1, sample size, the first of the first sample. This one we don't know. These three, I will give you. You will have a number for those. I have to give you those three things. Always, you'll have these three things. This one we're trying to figure out, so we don't know that one. You won't have that one, but you'll have these three. The test stat is, again, the only other thing that changes is your test stat. So it's going to be your samples difference, the difference in your samples, minus the difference between the means, which again, since we're assuming that they're equal, this is going to be 0, so it's going to go away, divided by the square root of the standard deviation. So it's going to be, if you have two populations, you add their variances and take the square root, so it's going to be S1 squared over N1 plus S2 squared over N2, and then square root that. So this is your test stat. And then remember, for degrees of freedom, you're going to use the smaller n, whichever is smaller between N1 and N2, the smaller one minus 1. Okay, so here is our, this is H0, which again can be written like this as well, and this is the only part you care about, because this is just 0. All right, so here's my example. Researchers conducted trials to investigate the effects of color on creativity. Subjects with a red background were asked to think of creative uses for a brick. Other subjects with a blue background, their room had a blue background, were given the same task. And then these judges, judged them, gave them a creativity creativity score. Researchers claim that blue enhances performance on a creative task. In other words, the blue people should be higher than the red people. Test the claim using the 0.05 figure level. So here's the numbers that we give you. We have to give you these numbers, right? And we'll make this one, just doesn't matter which one you make, 1 and 2, because it'll be a left-tailed test or right-tailed test, but it'll work out the same either way. So I'm just going to make the first one 1 and the second one the second group. So I'm saying that the blue is greater than the red. So in other words, group 1 is less than group 2. That's going to be my claim. This is the group. This is the N1, X bar 1, S1. This is N2, X bar 2, and S2. Good. This is my second sample. This This is my first sample. All right, so here, since we're claiming blue enhances, we're saying that the red is less than the blue. The mean of the reds is less than the mean of the blues. That's my claim. Since my claim is always equals, H naught's my claim, and H naught is equals, and H1 will be my claim. So H naught is always equals, so H1, since my claim is less than, H1 becomes my claim. That's my step one. Should be writing this down. H naught is this, H1 is that. And you can make these both R's and B, an R and a B if you want, or just make them this one a 1 and 2, just as long as they match up. Step 2, find the critical value. Significance level is alpha is 0.05, so my smallest n is 35. My degrees of freedom is 34. So I'm going to bust out my t-table and take a look at it, and let's see. 0.05, one-tailed test, here we go, and I go down and, oh wait, yeah, 0.05. And I go down and, is it one-tailed or two-tailed?
One-tailed.
One-tailed, this is wrong then. A one-tailed, 0.34. One-tailed should be 0.05, should be right here. So 34 would be right between these two. So since I don't have 34, I'm going to round down. So always round down. Don't round up, round down. So it should be 1.697. I got to change that. That's incorrect. 1.697. Oh wait, alpha one-tailed. Oh, that's right. Oh no, it should be this. Yeah, 1.697. Yep. So this really should be 1.697, but it's negative. So it should be negative 1.697 right here. And I'm through a picture, shaded to the left because it's left-tailed, and then calculate your test stat. So x bar 1 minus x bar 2 over square root of s1 squared over n1 squared plus s2 squared over n2 squared, square rooted. So here's my number. My x bar 1 was 3.37. X bar 2 is 3.97. And then divide by square root of my s1, which is 0.97 squared over n1, 35, plus s2 squared, 0.63 over n2, 36. And when you do that, again, start from the inside, work outward. So find this, add it to that. You have to do this all in one step because this squared will take precedence over the division plus that one. So you could just do it in one fell swoop. I'll go ahead and do that, I guess. You guys probably want that, I'm guessing. So it's going to be sorry, we don't want the part. We want to work from the inside out. So we'll do the inside part. The inside part first, which is 0.97 squared plus, divided by 35 plus 0.63 squared divided by 36, enter. Now I need to square root that. So I need to raise it to the 0.5 power. That's my denominator. 1.946, not 1.947. I'm going to do the top. 3.39 minus 3.97. I get negative 0.58 divided by the top, 0.1947. And I get negative 2.998 if I round. Negative 2.98 or 2.979. And that's what I got, negative 2.979. Perfect. So you throw that in here, and it's definitely less than, it's in the guilty range. So my critical value was actually even further over. So it means we're totally going to reject H naught. It's in the guilty range, right? So we have enough evidence to reject H naught. Give you guys a couple seconds to write that down. And so we do have enough evidence to support the claim The red background group has a lower mean creativity score than the blue background group. So this is sufficient evidence because we rejected H0. So we did reject H0, so we do have enough evidence. And then H1 is my claim, so we're going to use the word support here. Okay, the last thing I want to go over just very quickly because I know we're out of time is lab 5. All I need from you is the file, so your Excel Google Sheet, and then you don't have to worry about printing out stuff because just you have the file already. And then I handed this handout out to you guys, so I just need scans of the last 2 pages. So the last 2 pages, you have to fill them out. So it's this part here, pages, I think 5 and 6. So print these 2 pages out, or you should have them already, and then fill them out, and then send me the scans of those 2 pages along with your file, your Excel file. Okay, so that's all I need, and that's by next Wednesday. And do you guys want me to bring you back to number 5? I'm going to guess everyone wants to see number 5 again. So there's step 5 if you need it. All right, have a good couple of days, and I will see you guys on, is today Thursday or is today Tuesday? I think today's Thursday. Okay, yeah. Have a great weekend. And we will see you guys on Tuesday. Don't forget your homework on the first part of this stuff, the stuff we did earlier today. That's due on Tuesday. So work on that. All right, have a good one. Take care, everybody. Bye. Bye. See you Tuesday. I'll leave this up for a little bit in case you need it. Bye. Take care.
You too.
Thanks.